Welcome to Nature of Code in Rust and GGEZ. Today we're going to be working on example introduction.6, 2D Perlin noise. The idea here is that we're going to be creating this sort of image graphic, but obviously in Rust and GGEZ. So the Perlin noise, we sort of saw that it's a random number generating algorithm. I think that each random number is related to the previous one. So in this example, we're gonna show how it can make something look maybe a little bit better. If we switch over to our code, I've already copied over our template and added in all of our dependencies, specifically rand and noise. So the first thing I'm going to do is set it up with rand, and we'll just sort of see the static that it generates. And then we're going to switch it over to noise once we have that all working. So let's head on over to lib, and then just to make sure that this is all working correctly, let's do a cargo run here. All right, perfect. So I've got my full screen set up. Now this is a significantly higher resolution than what we have in the example, but I think that should be fine. All right, so the big thing that I want to do here is I don't want to have to generate essentially dots for every single pixel, every single frame. I think that's going to be a little bit too much and potentially destroy the frame rate and essentially, whatever computer we run that on. So I think I'm going to have everything happen in new, which is essentially setup here. And then we're going to do nothing in update or draw. We're just going to leave this like that. So I don't even need a background color in here. So we're going to reset that just a little bit. Okay, so given that, I also want to do a graphics present. I'm going to hand it the context. And then there you go. Everything should still be happy, and we should still be able to draw out everything that we need to. So with that in mind, we're going to create a circle that's 1 pixel in diameter for every single pixel. So let's go ahead and get the width and the height. Okay, so now we have a width and a height. We can now loop through this. So we can have our x in 0 through width. I do have to convert this into something, so we can just do a U32. It doesn't really matter. I'm going to be converting this back into an F32, so I don't really think it matters that much. And then inside of it, we also have to do another loop, which is the y. Okay, so once we have our coordinates essentially for every single pixel, we're going to create a mesh. Well, let me think about that, because I can actually maybe make this just a little bit easier on our computer by creating only a single mesh and not have to run draw a whole bunch of times, just a single draw. So I'm going to do a let mute our mesh is equal to a mesh builder new. Then inside of here, we can then just do the mesh dot circle and do our normal circle things. So we want a draw mode, import you and fill you. The point, where is this going to be? Well, it's going to be the x as F32 and the y as F32. Our radius, I'm going to do 0.5, so that way it's an exact 1 pixel size in the end, because that's the radius, not a diameter. Don't need a break. Tolerance 0.1, so that it's an actual circle. And color, let's make, this is where we need to choose the color they're going to make. So let's actually create this here. Color is equal to, I'm going to do a random color. like this. Let's actually name this brightness. That's exactly the same as they have it in the example. Now, to make a gray color, the RGB is going to be the exact same value as each other. So we can do let color equal to color new. And we're going to set this to be brightness 1.0. And then that color is going to be used over here. All right, so this will create a whole bunch of circles exactly where we want them to be. And then at the very end, we do need to build this. So maybe let's recall this like a mesh builder. And then we're going to have a let mesh is equal to the mesh builder dot build, hand it that context. And then we can graphics draw this. And then we don't need any draw params. So we can just give it the default ones. And I believe, let's see, what are you upset about? You need to be mutable. Oh, mesh builder. All right, I think that's working. We don't need you. No, oh no, we still have a warning. Oh, in this context, yeah, we're not using you. All right, no warnings, no errors. Let's see how this looks. Now, it does take a little while to load up the first time, but that's how long it takes this draw command, which is why I don't want to run it every single frame. This is a very large image for us to be doing this on, to like setting this many circles on. So that's why I only want to run it once. That being said, once it's run once, my computer doesn't really have any problem. It's just sort of staying here. This is what a completely random grayscale pixel, every pixel being set looks like. Now, let's go ahead and do the same thing, but we're going to set noise. Okay, so the biggest thing that we learned is that we're going to have those like the X-offs and a Y-offs for the noise. So first of all, we're going to have our noise function. And then we're going to have our mute. We call this the X-off. Y-off. Now, I'm not completely sure in this noise function if like they're exactly the same thing, if that leads to like any problems. Let's go ahead and make them like pretty far off. Here we have 10,000 separation. And let's also have a let, this doesn't need to be mutable. This is going to be like our incrementer. It's like noise incrementer. If you're hearing my cat, he really wants to go and bother my wife who's cooking upstairs, and I'm not letting him out of the room. So I will go and give him attention right after this video is done. We're going to do 0, 1. Okay, so the idea here is for every single one of these, we're going to increment our X-off and a Y-off. So we're going to start with the X-off. Well, I'm actually going to reset Y-off here for every single one of these, and X-off starts down here. Then after each of these Y's, we're going to Y-off plus equals to the noise incrementer. And then down here, we're going to do X-off plus equals to the noise incrementer. We're going to increment by the same amount. Okay, that gives us that. Now, if we want the brightness, instead of random, we want this to be the noise function. So we can get, and it needs an array of the X-off and the Y-off. But we don't just want to do get like this. We probably also want to map it. Well, do we? We do, because this is going to give us a number between -1 and 1, which is not really valid for a color. So we're going to need to do the map thing here. Okay, so let's pull in map. And if we remember how this works, we're going to give it the range that it can be. So -1.0 to 1.0, and then what we want it to be, which is 0.0 to 1.0. We save that, and then I think we should be good to go. What do we need to do here? Import the traits. Oh, and you need to be an as F32. All right, we have a warning, and we have some, let's see, where's our warning? We don't need the random anymore, so we can remove that. And I have some spelling things that my spell check is yelling at me about. I don't really care about those. Let's go ahead and run this and see what it looks like. And here we go. It doesn't look exactly like what we see in the example, and I sort of feel that that might be due to the Perlin noise for the library that I'm using. It just calculates it subtly differently. I did try playing around with a lot of different sort of like the noise functions that are available, and you can get really, really interesting results. Now, the next exercise is exercise 1.8, and let's see, I guess it's just 1.8 to play with the different values. I would also recommend playing with different kinds of noise generators just to sort of see what things look really interesting. Anyways, that is example 1.6, and I'll see you in the next video. Bye.